Now that we understand how dependency injection, aka DI subtrees work, let's build something a bit more complex so we can get a better understanding how and when we could use DI subtrees to benefit our real-world applications. In this lesson, we're going to use the Nest.js event emitter package, which provides a simple observer implementation that allows us to subscribe and listen for various events that occur in our applications. Events serve as a great way to decouple various aspects of our application, since a single event can have multiple listeners that do not depend on each other. To get started, let's open up our terminals and install the Nest.js/event-emitter dependency. Once the installation process is complete, let's open up our app module and register the event emitter module. Next up, using the Nest.js CLI, let's generate a new payments module. Let's also generate the payments webhook controller inside of that module. Note that we're passing the flat flag here just to instruct the Nest CLI to not create another nested payments-webhook directory. With all this in place, let's open up the newly generated controller and add a simple get route just for the demonstration purposes. With this endpoint in place, let's inject the event-emitter2 class using the standard approach. We need this class in order to dispatch events. Before we can proceed, we need to declare the payment failed event class that we'll use in this lesson. So inside of the payments folder, let's create a new directory called events, and in this directory, let's create a new file named payment-failed.event.ts. Inside of this file, let's define the following class that you can find below the course video. This event will represent a failed, possibly rejected payment. It exposes the static key property that we'll use to identify the event and takes two input arguments, payment ID, which is a unique ID that represents that failed payment, and meta object that we'll dive into later on. Now, let's declare event handlers or event listeners that will subscribe to the payment failed event occurrence and will process it accordingly. Let's open up our terminals and generate a new service called notifications service. Normally, we generate it in a separate module, but since we want to keep things simple here, we'll just use the payments module for now. Also, let's generate another subscription service class in the same module using the Nest CLI once again. Both services will listen to the payment failed event and will perform relevant corresponding actions. Let's start with the notification service, open it up, and declare a new send payment notification method. To register this method as an event subscriber, let's use the onEvent decorator, passing the paymentfailedEvent.key as an input parameter. Great. Let's follow the same steps for the subscription service, add a new cancel subscription method, and annotate it with the same decorator. Now, there's one limitation you should be aware of here. Event subscribers cannot be request scoped by definition, since Nest can't really track down what service controller triggered the events, as that would be against the loose coupling capabilities the events provide us with. Excellent. So last but not least, let's switch back to our payment webhooks controller and dispatch a random payment failed event with the webhook endpoint handler just so we can test everything out. Great, let's save our changes, open up our terminals, and in a separate terminal window, let's trigger the /payments webhook endpoint using curl. Now let's switch to the other terminal window, and as we can see, both event subscribers were triggered. Excellent. All right, so we already know how to emit and asynchronously process events. We are also aware of the event subscribers limitations, as they can't be request scoped. So now, what if we actually want to use a dynamic request scope provider from within the event handler? How could we access the original caller request object without polluting our event class even further and explicitly passing it through the constructor? What if we have a request scoped logger that we'd like to leverage inside of our event subscribers, or many other real-world examples? Luckily, we can overcome this limitation with the use of module ref and our knowledge of DI subtrees that we covered in the previous lesson. Let's open up our payments webhook controller and first modify the webhook method signature to take the request as an argument. Next up, using the context ID factory, let's generate a new context ID as we did in the previous lesson. Next, inject the module ref using the standard approach, and let's make sure we also register that request object for the given DI subtree. And lastly, Let's update the context ID that we pass as an input parameter to our event constructor to be context ID instead of null. Perfect. Let's save our changes, and before we continue, let's create a new request scope provider that will represent our event context. Inside the payments directory, let's create a new context folder, and inside of this folder, let's create the event context file. Inside of this file, let's paste the following content that you can find below the course video. So basically, this class will serve as our event context that provides us with the caller request object. Let's also not forget to register this class as a provider in our payments module. With this provider registered, let's navigate to our notification service and first inject the module ref provider using the standard approach. Inside of our send payment notification method, let's retrieve the event context object using the event.meta.contextID, and let's log down its URL. Let's repeat the same steps in our subscription service as well. Once finished, let's save all of our changes, open up our terminals, and trigger the webhook endpoint once again. And as we can see, both subscribers can now access the request object and can share the same DI subtree. Great! So in this lesson, we only use the request provider as an example, but you can actually resolve any request scope provider you wish or need. Furthermore, since we're using the same context ID in both subscribers, if you request a, let's say, request scoped logger instance, as we mentioned earlier, it will only be created once and shared between all event handlers. Hopefully, you can see the multitude of use cases and possibilities available to you now with this new DI subtree superpower.